So I wanted to go over wireless LAN configuration in today's class session. This is in module 13 from course 2, which is the Switching Routing Wireless Essentials course. So we'll go over the configuration for wireless LAN networks, and we'll go over some troubleshooting as well. And we'll do a little packet tracer exercise to kind of hammer home the configuration steps. So home networks and small businesses often have a wireless router included in their network. These are usually connected to a broadband modem, think like Spectrum, cable modem surface or DSL. They usually have some ports. These are usually switch ports, not router interfaces. It's used to connect wireless devices. You can see in this example, this has 4 switch ports and then a WAN port for connecting to the internet through the cable modem or what have you. Wi-Fi modem Wi-Fi routers provide security, DHCP, NAT, and quality of service services, or QoS. Security would often include firewall services, parental controls for home networks, things like that. Most wireless routers are pre-configured to connect to a network, and you can also set these up using a web-based interface, so you can modify the settings as needed. So typically you connect with like a laptop or a desktop, for instance, and open up a web browser to the default IP address of the Wi-Fi router. 192.168.1.1 is the most common one you'd see out there. Typically, this information is found in documentation that comes with the Wi-Fi router. Sometimes it's found on the bottom, like on a sticker on the bottom of the router itself. First thing you should do whenever you're setting up a wireless router is change the default password. Often that is password, is the password sometimes, so it's always a good idea to change that. These are the basic initial steps for setup. After changing the password, of course, you would log in with the new password and change the default DHCP IPv4 address. And once that's renewed, you would log back into the wireless router with the new IP address. After you finish changing the default login information and the IP address, you can set up the wireless. All Wi-Fi routers come with a default SSID or SSIDs oftentimes. You need to select which mode of 802.11 standard that you would need. Are you using type N, type AC.AX? Do you have legacy equipment on site that would require an older standard like a G standard, 802.11G, for instance? You assign an SSID to the wireless LAN. A lot of times you have multiple SSIDs. For instance, one dedicated for a 5 gigahertz signal and one for a 2.4 gigahertz signal. You'd select the channels for each SSID. Remember, there are certain channels that do not overlap with each other. And show that later. A lot of times Wi-Fi routers do not have a security mode configured on the first time you turn it on. So it's a wide open Wi-Fi signal. The strongest widely available security mode is WPA2, but WPA3 is making its way out there. So you probably see that, within the next year. I would expect. And of course, you need to configure a passphrase for your SSIDs, and it should be a secure passphrase. So most homes and small offices only require one wireless router, but you can create a wireless mesh network with multiple access points. Notice in this example, there are 2 access points, and these are using 2 different channels that do not overlap with each other. 1 and 11 have no overlap in their frequency range. So there's no interference between the 2. Typically, wireless routers are assigned a public IP address by the internet service provider and are set up with a private IPv4 network within the local area network. NAT allows you to an entire network to basically communicate with the outside world over a shared public IP address. We go into more details on NAT in course 3, but in this module 13, it does show you how to set up NAT on a wireless LAN. It's configured over a graphical user interface. QoS is another service that is covered later in course 3, but it is something that can be set up easily within a wireless router. QoS prioritizes live traffic, such as streaming audio and video, and most modern wireless routers offer QoS. It's hard to watch Netflix or play live online games, streaming games without QoS enabled. And port forwarding. This is also something that's covered later in more detail, but port forwarding is used to enable certain communications. Most Wi-Fi routers block TCP and UDP ports to prevent unauthorized access from the outside. But if you're running a Minecraft server in your home, you need to open up some ports in order for your friends to play with you. A lot of online games require that as well. If you're running a Plex server, which is a multimedia server, you need to open up certain ports for to be able to watch movies remotely if you're running a Plex server, which I have. All right, so this is a larger wireless LAN example. Larger wireless LANs often are controlled with WLCs, or wireless controllers. This topology, we have a lightweight AP, which is also known as a controlled AP or controller-based AP. These are controlled by our wireless controller, which is indicated right here. This topology is much more scalable than using autonomous access points, where you have to manually configure each access point. In this topology, all access points on this network will be controlled by this wireless controller right here. This topology only shows one access point, but these wireless controllers can access multiple access points, sometimes many more access points. So a wireless controller provides more services and features. It's fundamentally similar in terms of how to configure it. It configures the same way as a wireless router from a user standpoint. It's got a web-based interface for management, just like a wireless router would. This is an example of an interface on a wireless controller. Notice it shows an access point, shows the MAC address, the IP address, and some other information, important information about the access point. If you're a network administrator, you're probably going to be doing a lot of your work within the Advanced tab. In this, you can have much more advanced controls and more detailed ways to manipulate settings on your wireless, LAN. Wireless controllers have switch ports as well as virtual interfaces. These switch ports are trunked, which allows you to have multiple VLANs, multiple VLAN traffic going over them. Each switch port can support multiple access points and wireless LANs. In this example, this is a Cisco 3504, and this can support 150 access points and all 4,096 VLANs. So what type of wireless LAN network would need 150 access points? You ever been to Disneyland or Disney World? Maybe a large sporting, stadiums like Gillette Stadium in Boston. Probably, I don't know if they'd need 150 access points, but they're going to need, more than a dozen. There's going to be dozens and dozens, and maybe 150 might not be that far off. Definitely a resort like Disney World would require, close to that, if not more. So some wireless LAN networks require authentication services, or AAA, which is authentication, accounting, and authorization. Authentication, authorization, and accounting, actually. That basically requires users to authenticate off a server, such as a Windows server. And it is required if you are going to use WPA2 Enterprise authentication, which is more secure. This topology here shows, a radius server on the network, and everybody would be authenticating off of this radius server in this example. This is an example from the book. The administrator has set up VLAN 5 as the interface for the wireless LAN. Section 13.3.7 in the course book shows the specific steps to create this topology. We're actually going to walk through Packet Tracer 13.3.12, which does basically the same thing. Let's bring that up. I think I have that open already. Okay, so this is in the online course. This is, as I said, it's 13.3.12. And it is setting up and configuring a WPA2 Enterprise wireless LAN with a wireless controller. Let's see, it's not a very big network, but this is very scalable. You could add additional access points if you wanted to, but it's got a radius server, it's got a layer 3 switch, a wireless controller, and it's got one access point currently. And it's got the addressing table. So let's just step through this. So we'll configure the new VLAN interface on the wireless controller, configure the new wireless LAN on the controller. It's all these steps basically. Eventually we'll configure the radius, or configure the wireless controller to use the radius. Actually, the radius is already pre-configured, and it's setting up a radius server, and AAA on a radius server is actually outside of this course. That's something you would go next door to AXA for. So let's just go right through this. I'm going to go on to the admin PC. I'm going to resize this a little bit. open the browser. Got to go to the IP address of the wireless controller, which is listed up here. I'm going to use HTTPS because it requires a secure connection. And what was the username and password? It was admin and Cisco123. And this drops us into our graphical user interface management for the wireless controller. So we'll click on management. Actually, no, we'll click on controller interfaces. See what we have in there. So we have the management and the two set up in there. So we're going to create a new one. We'll call it wireless LAN 5 or WLAN 5. And we're going to use VLAN 5 on that. I think that says. Yep, right there. It says use physical port number 1. And we set an IP address of 192.168.5.254. And full class C on the mask, or /24. Okay, so we'll apply that. We'll go up and save the configuration. All right, now step 2, we'll configure the wireless controller to use a radius server. Security new. And the shared secret. In real life, you would not be using the same passwords, but this is just an example. I'll create a new wireless LAN. Okay, so enter the profile name. It gives us the profile name of floor 2 employees. And SSID is SSID 5. And VLAN ID is 5. Okay, you want to make sure that you click the enable checkbox when you're creating a new wireless LAN. It's easy to forget that. And the interface group, we're going to use wireless LAN. And then we'll go to the advanced tab. Go to the Flex Connect section, which is down here. And it wants us to enable both Flex Connect local switching and Flex Connect local off. Apply that. And so instead of WPA2 PSK, we're going to configure this to use WPA2 Enterprise. Let's see. We apply that. Okay, there we go. Save it. And that brings us to the wireless LAN ID configuration. Let's look on security. On the layer 2 tab, it's right now set to none, which is not good. Change it to WPA, WPA2. I'm going to enable WPA2 policy. We're going to click 802.1x to authenticate. Now go to AAA servers and open the drop-down. Let's see. Oh, oh, okay, I think I skipped that. Okay, so go back to here, check that security. Click the wireless ID. Click W. See, make sure we chose the right one. WPA, WPA2. Under WPA, WPA2, enable WPA2 policy. We did. Click 802.1x under authentication key management. Let's go back to here. Double check this. Did I not do this? Okay, let's. Okay, I don't think I did this. That's probably why. Okay, so the IP address of the radius server. Yeah, I did not do this. Somehow I skipped that step. Hey, it can happen to anyone, right? All right. Okay. Now we're showing a radius server there. So let's go back to our wireless LANs. Wireless LAN ID 5. Make sure that that's still saved in there. So we're using SSID 5 for 2 employees. Go to security. Now we'll select WPA and WPA2. WPA2 policy. 802.1x authentication. Go to AAA servers, and now we have our server, our radius server listed there. Sorry about that. We'll apply that. And we'll save the configuration. And we're getting towards the end here. We do need to configure a DHCP scope. So go to controller, interfaces. Management. And it wants us to record this information here. So it's using a 192.168.200.0 network, and the IP address is the last usable. The gateway is the first usable. It's a /24 network. So I think we can remember that 192.168.200. VLAN ID 1. No, just make a note. The gateway was .1. Primary DHCP server was all zeros. So bring that back up. Okay, you want to use the wireless control, use its own DHCP server, provide addressing. Okay, so on the left-hand side, expand the DHCP server. Make a little more space. No, I can just scroll over there. Okay, click new. This will be called wired management. And new scope is wired management. Click on that. Okay, pool start address. You're giving this 192.168.200.240. .49 is the last one. We provide the values from the network for that was 192.168.200.0 is the network address. Mask is a class C or /24.0. Default router is the default gateway 192.168.200.1. I think that's all they are asking for there. So click apply. And let's configure SNMP for management. Okay, so expanded. Click trap receivers. So you can scroll over and hit the new. Wireless LAN SNMP. It's enabled. Hit apply, which is this button right there. All right, and now I think the last thing we have to do is actually connect the host to the network. You can profile. So, choosing SSID 5. We're obtaining settings using DHCP. Security, we're going to use WPA2 Enterprise, which is the whole point of doing this. It gives us the login information here. Not a very good username and password combination. I think I mistyped that, so let me retype that. All right, save that. Let's go fast forward in time a little bit. Okay. There we go. Fast forward in time a little bit, and we have a wireless connection. Let's ping the radius server. That's successful. We'll ping the layer 3 switch. No, that's successful. Took a couple tries, but it's successful. And we'll ping the default gateway. That's successful. So other than me skipping a step, that actually went through pretty smoothly. So anyway, it's on your book. I'd suggest, practicing with this. There's also another packet tracer out there in that same module 13.4.5, which does a little more with troubleshooting. Let me go over the troubleshooting steps with you really quick here. These are your 6 steps of troubleshooting. You identify a problem. Usually it's a good idea to actually speak with the users and find out what's going on. Does the wireless go down, a lot? Does it go down at a certain time each day? Is it just slow? Just find out all you can from users. Then establish a theory of what the probable problem is, and then test that theory to determine if that is the cause. And once you find out the cause, usually you can, you know what your plan of action is going to be to resolve the issue. The 5th step is to verify that everything is up and running. Ping everything, make sure that you have full connectivity. And the last step, which a lot of people, neglect, unfortunately, is to document everything. Document all your findings, what you did, what the outcomes were, what did you do to fix the problem? Because a lot of times, the same problem, if somebody goes in and makes a configuration change, the problem you fixed, before is going to be, become a problem again. But if you've documented what happened, how you fixed it the last time, shouldn't be a problem fixing it again. So anyway, Packet Tracer 13.4.5 is a good practice packet tracer, and I have a walkthrough on my YouTube channel if you need any help with that. And that concludes this presentation of wireless and LAN configuration.